Hi everyone, this is Asma Mushtaq from the EEVIBES, and in this video lecture I am going to explain an application of the linear algebra where you can see uh, linear algebra can be used for balancing the chemical equations, and we can determine the values of the unknown coefficients like A, B, C, D for this particular chemical reaction. If you look at this chemical reaction, you can see that the elements that are involved in this equation are nitrogen and oxygen. All right. Our first task is to determine the elements that are present in it. The next task is to write the A as it is, which is the unknown coefficient. And now I will write the value of each of these component on the product and the reactant side. So hydrogen in this first element is 0. So I will add 0 over here, while one atom of the nitrogen is present and two atom of the oxygen are present. Fine. Then plus B times of hydrogen is 2 unit while nitrogen is 0 and oxygen is 1. These reactants combine to give me the product having the same coefficients, and these are 1, 1, while two elements of the oxygen are present, and similarly D 1, 1 and 3. Fine. Once you write this chemical equation into the vector notation, the next step is to write it in the form of the system of the linear equations, which is Ax is equal to 0, and then I will apply the Gauss elimination method for finding the values of these coefficients. For writing this system of in the form of this system of equation where the right hand side is equal to 0, I will have to take all these products on the left hand side, making the right hand side equal to 0. So if I do write it in the form of a matrix, I will have 0, 1, 2, which is the first vector, then 2, 0, 1, second vector, then 1, 1, 2. Now you will see I will add the minus sign before them because I have taken them on the reactant side, indicating that these were actually the products. All right. The variables involved in this system are A, B, C, and D. Fine. While on the right hand side I will have 0, 0 and 0 because all the products have been moved towards the reactant side. The next step is to write the augmented matrix of this system. That is, after writing the matrix in the augmented form, the next step is to apply the elementary row operation. In the elementary row operations, first we have to see the first element of the first row is 0 or not. Since this is my pivot entry, this is my pivot entry, and this is my pivot entry, you can see that this pivot is equal to 0, and it is necessary for applying the Gauss elimination method that the pivot shouldn't be 0, and if it is 0 you need to swap the two rows. So in this case we will swap row 1 with row 2, and after swapping we will have, now you can see after the swapping the pivot has become 0. Now the next step is to make all the entries below the pivot entry equal to 0. So I need to make these entries equal to 0. Since it's already 0, so I don't need to perform any operations on R2, and I will perform the operation on R3, that is represented like operation on R3, and it is what? R3 minus 2 times of R1. Alright, because in this way this entry will be 0. When I will perform this operation, I will have the matrix. There will be no change in the first row. Okay. No change in the second row. And this will be equal to 0. This will become 1. This will be 0. And it will be minus 1. While right hand side remains 0. Fine. Once I have performed this operation, the next pivot is this 2 and I need to make this value equal to 0. Fine. So the change will be made in R3 again, and what will be that change? R3, then minus of the formula, then we write the value that we want to make equal to 0, which is 1 in this case, and divided by the pivot, which is 2 in this case, and then we write as a product row where the pivot is residing. So in this case it is equal to second row. Fine. Let's perform this operation on the matrix now. So when you will perform this operation, you will get the matrix like that. Here you can see, let me highlight it again. This was the first pivot and we had to make all entry equal to 0. That is done. Similarly, this is my second pivot and all the entries below it are 0. Now there is no more row behind where I can make the values below it equal to 0. So that's why the next step is to perform the back substitution method. In the back substitution method, we start from the last row and we start solving for the unknowns parameters. All right, so I will have, these were the coefficients of A, B, C and D in that we assumed initially. So this is 1 over 2 times of C minus 1 over 2 times of D is equal to 0. When I will take the LCM, this become 2. So C minus D is equal to 0. Let's cross multiply them and you will get C minus D is equal to 0. This implies C is equal to D. I can choose any value of D from the set of the real numbers except 0. Why? Because then the reactants and product will become 0. Alright, and we don't need to do that. Fine. So if D is equal to 1, then automatically C also becomes equal to 1. So these are the two values that we have determined. Fine. Now let's move to the second equation. Second last equation, so it becomes 2 times of B minus C minus D is equal to 0. So 2B minus 1 is equal to 0. This implies 2 times of B is equal to 2 and hence you will have B is equal to 1. This is the third value that we have determined. Now let's move to the last equation. I will solve it over here. So we will have A minus C minus D is equal to 0. So A is equal to C plus D. Hence A is equal to 2. Since C and D both are equal to 1. So the values of the unknown A, B, C, D are written in the column form. A is equal to 2 while B, C and D all are equal to 1. Let's verify our result by going back to the original equation. So I will erase these values and substitute the determined values. So A, B, C, D that were unknown, let's substitute the values. A is equal to 2 while B, C and D are equal to 1. So 2 atoms of the nitrogen are present on the reactant side. Fine. 2 atoms, while on the product side 1 plus 1 is equal to 2. So this is fine. Similarly, 2 into 2, 4 plus 1. 5 atoms of the oxygen are present on the reactant side and you can see 2 plus 3, 5. So 5 atoms of the oxygen are present. The last one is the hydrogen. 2 atoms of the hydrogen were present on the reactant side and you can see 1 plus 1 is equal to 2. And hence you can see this chemical equation is balanced by the linear algebra. Thank you for watching. Also don't forget to subscribe and like to my channel. If you have some question, you can drop the questions in the comment section. Allah Hafiz.